Hello, I'm the Autopilot, and I would like to show you a tool that I created for debugging in Neos. So let's assume you have created a nice interactive object, and it's supposed to react to you, move up a bit in an irregular way. So you did some math to figure out how to do that. But suddenly, bam, it's gone. Hmm, what's happening? Using the inspector, you figured out, the position I'm driving is not a number. And after going through your logics a bit, you figure out this value is not a number. What do you do? How is it calculated? It's calculated in a for loop. That's ugly because in regular programming, you usually would now stop your program and step through it line by line or iteration by iteration and see how the values are changing. But you can't do that in all occasions. For example, in Neos, we can't just stop the world or the for loop. We can't stop Neos. So what do we do then? Uh, Alternatively, you can write messages, do logging, and figure out when is the value each time you do that thing. And then you can close in on the error this way. So this is what you can do. And I created a small tool I call Value History. You can find it in my public directory. And you just spawn it out. And it looks like this. So it has an imports input, imports output, a value input, a reset button, a checkbox to listen for changes in the value input, and you can make it automatically scroll to the bottom. So you're always in the know of the current things that are happening. So what we do as a first step, we want to close in on how this value changes actually, because it's always a bit hard to remember all the value changes. So we now connected the value input and listen for changes. So it's not a number at the moment, of course, because the program is still running. So let's reset the program. So we start at 0, then go to 1, 2, 2.25, 2.65, 2.7 something, and then suddenly not a number. Interesting. But where is actually the input of our calculation? So everything here is constant. So the only thing that changes is actually the input to the for loop. So let's just, oh, that broke a bit. Interesting, Neos. Fine, we will deal with that. So let's connect that to the value history as well. But now we need to connect two inputs to it. So there's actually a trick. You use string format in there. Give it maybe 3 inputs. Maybe we need more. So just use some formatting codes here. So if you're interested in that kind of thing, look up C# formatting format. So this is our input. Now we will put this as the first input and our float that we get as a second input. Then we see what's going to happen. Oh, we should maybe put some spaces in between or something like this. So now we can reset our program and see it's inputs 0, we get 0, 1, we get 1, 2, 2, 3, 2, 4, something, 6, okay, 8, okay, 9. What the heck is going on 9? So we have a problem with input 9. Now we can stop our program and just disconnect it completely from the for loop, because now we can reproduce the error. We know what inputs are necessary to produce an error. We know we need to put in 9 and hit an impulse on the for loop. Then we get our problematic result. There it is. So what do we do with this information? Because we have a for loop here, we can't stop it, but we can log values using the impulse input. So the way that works is you have your debugging message put into it, and you now create this connection in your impulse line and just connect the value history in between. So now you get the impulse before we write to the variable. So we can listen to the value that we are calculating. So basically we now, and also what we can do, we can put in the for loop iteration. And we have the old value and the new value. So, and we put some space in there. Good. Okay, let's run that and see what happens. So at the beginning, we have a value of 0 and it becomes 1. Then we go from 1 to 2, 2 stays 2, 2 becomes 2 point something, blah, blah. So at the end, at the last iteration, we go from 3 point something to not a number. That's interesting. So that plus gets in 3, but returns not a number. So something seems to be off with the other operand, division. And if you know floating point division, you know that you get not a number if you divide infinity by infinity or 0 by 0. So let's look at the inputs from that. So we just look at that and that. And let's give us a reminder what we are actually looking at. So that's the first one divided by the second one. And let's just play back the program again. So we get 1 by 1, 2 by 2, 0 by 3, blah, 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 blah. And on iteration 8, we get 0 divided by 0. Good. So why is it 0 divided by 0? Let's find out. So this time we can actually do that in our head. So we get an 8 here, plus 1 is a 9. And then we do modulo, which is the remainder of a division. We divide 9 by 3. You can divide that. The result is 3, remainder 0. So the output is 0, that goes into division. And we have this part here, 9 divided by 9, that's 1, and the remainder is 0. So we are dividing 0 by 0 and get, as a result, not a number, which is exactly the thing we didn't want to have. How do we solve that? Well, that's up to you, because you created this code. So this is summarizing all the things of my value history. I hope you have fun with it, or at least are successful finding all the bugs. Have a good day.